Okay, so this is on page 381, number 61, and it might be a little bit confusing because we only have one average, one expected value, and one standard deviation, but we're going to combine them. So let me talk about this a little bit. So car 1 that they look at is a little bit below average as far as the emissions, and car 2 is pretty bad. It's much higher than the average, more than one standard deviation out. So the mechanic says, well, what's the possibility that I would get these two cars? So we're going to look at the difference between the two cars. Now, what we're going to do is we're going to subtract these two, and the difference between them is 0.8. But let's get started. So if we subtract this expected value from itself, right, we're going to use this as we're combining these two expected values or averages. So what you would do is, it might look something like this. So we're going to subtract the expected value from itself, see? X minus x is going to give us 0. But don't forget, the standard deviation minus the standard deviation, well, we always add the standard deviations. So it's going to look like this. 0.3 squared plus 0.3 squared, add them together, take the square root. Okay, let's see. Well, let's take a look at the new standard deviation. So there we have it. We're going to combine, or I always say combine, but we're actually subtracting these, the expected values and the standard deviation. And here's our new expected value and our new standard deviation. So the expected value is we would expect a car to have about 1.4, and two cars from the same population would both have an expected value of 1.4. So if we subtract them, we would get 0. But this is the actual values right there. Okay, so let's continue. Okay, so the difference between the two cars, if we look at them in this way, whoops, did it again. Okay, so if we look at them this way, the second car minus the first car gives us 0.8. So what are we going to do? Well, z-score. So our z-score is going to be the value we're interested in, which is 0.8 minus 0 divided by the standard deviation. There it is. Okay. Let me do that. So that value, it looks like it gives us 1.886. So what do I do with this? And they said, well, what's the mechanic says, what's the probability that I get these two cars this different or more, right? So we're going to do normal CDF. And remember, you put second vars and find normal CDF. And what you end up with, we go from, of course, negative 1,000 to 1.886. Anyway, that number is 0.97. What does that mean? I always like to draw this graph, right? So what that means is 97%. If we took two cars, 97% of the time they would be down here. But the fact that there were 0.8 difference is up in this region. So what we need to do is 1 minus 0.97 gives us a 0.03. So we have a 3% chance that the difference would be that much or more. But one last thing, we subtracted the small one from the big one, right? Well, what happens if we happen to subtract the big one from the small one? Well, we would end up with a negative 0.8. So we do the same process, and it would be over here, wouldn't it? Okay, so we're going to look at these two parts of the graph. This is if we subtract and get a negative. This is the fact that we subtract and get a positive. So in essence, there would be a 0.06, or if we do the conclude part, there is a 6% chance of this happening. Taking two cars and subtracting them and noticing that the difference is 0.8 or more. Okay, so I think we're at that point where even if you do look in the back of the book sometimes and get the answer, you're like, well, yeah, but I don't know how to get that. Anyway, here it is. This is how you get it.